Good day and welcome back to class. Today we are going to be talking about physics, and you should not panic when you see physics questions. All you have to do is calm down. So let's see some of the questions we are having
and the
right
units.
here. So the first question
units
says
and
the unit of capacitance is A. Farad, B. Coulomb, C.
Present.
Henry, D. Now ohms. Farad, of course, is used for the unit for capacitance. So it is symbolized F, capacitance. Is symbolized F. And this farad can be measured in different ways. We have microfarad, we have picofarad, we have attofarad, and that is just how to measure the simple units of capacitance. So capacitance is measured in farad. So now we want to see the next question. The derived unit of pressure can be expressed as which of these? Pressure. Now we need to know that pressure is equivalent to force over area. And from our previous knowledge, we know that force is mass times acceleration due to gravity over area. Now we need to analyze this because mass is a quantity that is measured in kilogram, and acceleration is a quantity that is measured in meter per second squared, and the area is measured in meter squared. So using the simple analogy here, we can just bring in our law of indices and solve this division. So looking at this, we are having kilogram, and then we have m raised to the power 1. Ordinary m simply means m raised to the power 1. Then s raised to the power minus 2. As you can see from here, this is divided by m raised to the power 2, which can be expressed as m raised to the power minus 2. So we can see that this base and this base are the same. Using the law of indices, we bring them together. So we have kilogram, m power 1, m power minus 2, and s power minus 2. In between these two m, we have times. And from the law of indices, when we have similar bases, we can just choose one of them and then combine the powers with plus. So we have kilogram, m power 1, the times becomes power plus, then minus 2, s power minus 2. So let's see what this gives us. Bracket means times, plus times minus is minus. And that will give us 1 minus 2, which is going to give us what? Good. That is minus 1. So we have kilogram, m power minus 1, and s power minus 2. Now going back to the question, we have kg m power minus 1, s power minus 2, which is going to be option B, correct. The next question is this: which of the following units is equivalent to what? Which of the following units is equivalent to what? Now, watt is a unit for measuring power. Watt is a unit for measuring power. And watt is symbolized capital W. So when you see capital W, it refers to watt. Check your bulb, the bulb in the ceiling, the bulb you use at home. They are all rated wattage. And we know that power is to determine done divided by time. Work done divided by time. And now, what is work done? What's the formula for work done? So work done is given as force times distance all over our time. Our time is given as seconds. So let me write our time. So we remember that force is given as mass times acceleration. So I will remove this and put in mass times acceleration, then times my distance over here, all divided by my time. So now let's figure out the unit for each of these quantity. Mass is measured in kilogram, acceleration is measured in meter per second squared, and our distance is measured in meters, divided by our time, measured in seconds. So we want to use the law of indices to solve this simple expression. So we have kilogram, ms raised power minus 2, n times this divided by s, mean s raised power minus 1. So we can bring this together as s, having same basis with multiplication in between. So we have to add the powers, meaning that we have kilogram, m as well, m, s power minus 2, s power minus 1. And this would give me kilogram, m and n, that's m raised to power 2, right? M raised to power 2. So looking at this, we're having s power minus 2, s power minus 1. So we use law of indices, and that will be s raised to power minus 2 plus minus 1. So plus times minus is minus. So that will be minus 2 minus 1, which is minus 3. So I will erase this to put my minus 3. So going back to the question, let's see which one works out well. Kilogram, m raised to power 2, s raised to power minus 3. And where do we have that? So it's right here, B. So now let's see question 4. The SI unit of power is A, N. N is for Newton, and Newton is for measuring force. B, Pascal. PA is for measuring the pressure of gases. C, wattage. We know that wattage is the unit for power. D, joules. And joules is the unit for energy. So the right option is going to be C. Question 5 says, which of the following units is derived? Which of the following units is derived? Now we have two types of units. We have the fundamental unit and we have the derived unit. Now the derived unit has to do with combination of two or more fundamental units using basic signs, whether division or multiplication of two or more fundamental units. So which one is the derived unit? From this place we can see that N, which is Newton, is the derived unit. And how is that the right answer? We know that force is measured in Newton, and force is combination of mass times acceleration. So mass is measured in kilogram, which means mass is a fundamental unit. It's a singular quantity. We have acceleration, meter per second squared. Acceleration is a derived unit because it is combining two different meter units, meter and mass, second, and meter and second. So acceleration is a derived unit, which also implies that force is also a derived unit. Force is also a derived unit. So from here, we have Newton to be the right answer. Kilogram is a fundamental unit. This M means meter, the length or the distance measured in meter is a fundamental unit, and K, Kelvin, as temperature. Temperature is also a fundamental unit. And now let's see. The question we are having right here is question. The dimension of momentum are, which of these is correct? We need to firstly figure out the formula for momentum. And momentum is given as mass times velocity. Mass times velocity. Now let's break this down. And velocity is given as what? So we have mass times velocity, displacement over time. So we have displacement over time. So we need to figure out this. Mass is measured in kilogram. Displacement or distance is measured in meters. And time is measured in seconds. So this would be given as kilogram meter per second. So this is the unit, but not the dimension. Now let's talk about the dimension. Kilogram is for mass, and mass is symbolized letter M. The dimension for mass is M. Meter is for length, and it is symbolized L. While S, which is second, is for time, which is symbolized T. So bringing this dimension in these units, we are going to be having kilogram M, meter L, second T per minus 1. So this is the dimension for momentum. So which is the right answer? C. And that is just how you can figure out the right process of solving questions on units and measurements. Thank you.